Hi, I'm Harel Safra, and thanks for being here. I'm going to talk a bit about creating Terraform providers. I'll try to provide a practical guide on how to do that because I tried to find docs and work through how to do it, and it was a bit problematic for me. First of all, we'll have a bit a refresher about what infrastructure as code is. I assume it's a well-known subject here. We'll talk about where should you start, and we'll do a demo on how you create a provider. Yes, it will tempt the presentation gods to kill the demo, but I'll try to do that. First of all, a bit about me. I'm Harel Safra. I'm a data platform engineering team lead at Riskified. My team is in charge of all online databases, online data stores around Riskified, and it serves, we have relational databases and graph databases and search engines and key value stores, the works. And we manage everything that running in production, starting from deploying the servers up until creating code toolkits to allow teams to work with. We have a lot of infrastructure and really believe in infrastructure as code to manage all that. Otherwise, it will be scripts all down. We installed a database. Called Aerospike about 3 years ago, and we started managing it. And we manage everything on the infrastructure side, servers, etc., with Terraform. But we found ourselves lacking in user management, and that's where I started the journey. There was a backlog mission. It was stuck in the Jira backlog for months, and then I decided to just go ahead and do that. Infrastructure as code is the programmatic definition of infrastructure elements. I assume we all know that, but infrastructure can be a lot of things. It could be VMs on your cloud. It could be load balancers. It could be auto-scaling groups. All of these are standard, but it can also be users in a database. It can be tables. It can be individual rows that you want to manage and redeploy when you deploy the application. So it's not just infrastructure, the low-level infrastructure. It could be all of the things above and more. It allows repeatable, documented process to deploying infrastructure, to managing it, to changing. And there are two general approaches. There's the imperative approach, the declarative approach, where you define what you want to do. And the IAC tool does that for you, like Terraform or OpenTofu. You can also have the imperative approach when you write more verbose logic to try and to accomplish what you want to do. And I'm going to talk about Terraform. Terraform providers are the infrastructure between Terraform core, which is the CLI that you run, and the infrastructure API. They provide the adapting between Terraform concepts like resources and infrastructure concepts like a VM. They interface with Terraform core over RPC, and there are a lot of published providers. I've updated the slide deck today, this morning. There are 4,500 providers, and it's counting. And the important thing to remember that anyone can create a provider. You don't have to be from the company. You don't have to work at HashiCorp, or you don't have to have any kind of association with the infrastructure you want to manage, except that you want to manage it with Terraform. And there's a provider, or there's the provider, and you want to work on that. So where do I start? Start a bit about architecture of how this all works. So we have Terraform core. Terraform core is a fancy name for the CLI Terraform that you run to apply, to plan, to do your changes. It interfaces over RPC with a Terraform provider. Terraform provider is written in Go, and Terraform core will interface with RPC over RPC with a Terraform provider and for its operations. Terraform provider will wrap usually a client library that's written in Go, and adapt Terraform nomenclature into the infrastructure nomenclature. And the client library will then interface again with the infrastructure itself. It can be over HTTP, and this is all the samples that you'll find online. HTTP, web services, RESTs. But it can also be gRPC. It can be system calls. You can create a file locally, you manage that. And that's a demo you'll see later. You can run SQL commands, API commands. Everything that has an API can be wrapped in a Terraform provider. The API is the main component that you need to adapt. So find an API, the correct API, the most popular API. And if there's a native Golang client, use that. You don't want to reinvent the wheel and write APIs that are already available. After you found the API, the next step is obviously Go. You need to know enough Golang to write a provider because it's written in Go and Go exclusively. So Go is a high-level programming language. Get versed in that. I use a step-by-step tutorial. That's at go.dev/tour. It runs you through variables, control structures, loops, interfaces, everything that you need to do. It's not a deep level understanding of Go, but you really don't need a deep level understanding of Go. You need to know how to write code. It's a quite simple language to learn and understand. It's compiled. I like the fact it's compiled very much because compiler will find errors and instead of finding type mismatches and stuff like that at runtime. But there are no exceptions. If you're written in Java, Scala, where there are exceptions, there's no exception. We have to go way back and check return variables for errors. Otherwise, your code will panic out if some kind of error happens. Docs. HashiCorp docs are verbose. They have a lot of data. They're a bit convoluted, and you have to find a way that they explain how to do things. I have used documentation. It's under the HashiCorp site /Terraform/plugin. There are a few different types of plugins that frameworks that you can use, but use the latest one. Obviously, it'll be easier for you. You can scan the QR code if you don't want to type all the URL over there. Wait for a sec. After you have learned Go, you found the API, you understand what you need to accomplish when writing the provider, the obvious next step is writing the provider. So first of all, a bit about the demo we'll use down the line. It's a simple demo. It's a provider to manage lines, simple, full lines in a text file. All files are managed in a single path, so the provider configuration applies a single path to all files. And a file resource has a name, obviously. You have to create it with a name, and it has an array of strings, and that it writes to the file and manages. The demo that you can download has the file API. It provides a few primitives that you can work with files, so when you're experimenting with a provider, you don't have to write primitives that access files. And if you can see on the left side, your left side, you can see resource in Terraform-ish, where you have file name and lines array. On the other side, you can see it translates into a single file that has line 1 and line 2. You can download that from my GitHub profile. I'll scooch over a bit. There's a QR code over there. The Terraform plugin framework is the recommended way to create a provider. There are a few ways. HashiCorp have changed the recommended way a few times. There was the plugin SDK and SDK v2. The plugin framework, with the latest release, is the recommended way. It's the easiest way. It will allow you it will take all the communication responsibility between Terraform core and the plugin from you and allow you to write your business logic and not have anything just related to communication inside that. When you want to start a provider, the easiest way to do is start from the Terraform provider scaffolding framework under HashiCorp, clone it. It will have a few boilerplate setup for you around GitHub Actions to compile, around documentation, around make and build. It's a good place to start, and you clone that. Actually, you create a repo from that because it's a template, and then you can start moving on from there. You have, obviously, when you're provisioning infrastructure, you have to have a few primitives that you need to implement. The basic operation you need to implement is obviously to create a resource, read, update, and delete. And these operations do two things. They provision the infrastructure, but they will also instruct Terraform core how to amend the state. It's an important part of what they do, because if they just create a server and don't tell Terraform core to change the state that the server exists, Terraform core will try to create the server again next time. So they both do the API operations and then return the return value to Terraform core to allow Terraform core to amend the state and manage infrastructure correctly. The create operation provisions this resource. Read operation gets the current resource state from the infrastructure. As I said, infrastructure is servers, infrastructure could be database users, and that works in between them. Update will update the resource in place for attributes that support updating. If we take a server, for example, the disk size can be changed, but the server type, therefore, can be changed. Update will update resources, the attributes that allow updating in place. The delete operation will delete the resource. And Terraform cores can also use that for update operations that are not supported on a resource. So if you have a change that needs to destroy and create, it will be implemented through Terraform core calling delete, and then Terraform core calling create on the new resource. In the code, it looks like that. So this is you can see, yeah? Okay. And maybe zoom in. This is the repo that I cloned. This is a demo that you can see in GitHub, and the file resource has a few operations. As I said earlier, it has a create operation, a read operation, an update and delete operation. And all operations assume a pretty standard template. All of them start with reading what Terraform core has sent to our provider to do. It reads the data, and then it does a bunch of business logic and returns the result back to Terraform core. So in this case, the create operation of file reads the file name from Terraform code that was provided, and then it loops on the lines array and writes them to the line. And then it returns an operation, and it returns a response to Terraform core to allow it to amend the state correctly. The small operation, the small node, the file API, you can see has a read line operation, a write line operation. It can count the lines and remove and trim a file. Not all operations that a file supports, but enough operations to create and read files. I specifically made that limited because APIs are usually limited. You can't do everything with them. Back to the presentation. We have operations, and we have schemas and attributes. Schemas and attributes map between configuration blocks that we saw earlier, resource file lines, back into the arguments that the API needs in order to operate. So these schemas will define how a resource looks, what attributes it has, and what it doesn't have. Schemas contain attributes, and each attribute defines a data element that can be a type. It has a type. It could be a primitive type, int, string, or a few others. And it can be a complex type. It can be a map. It can be an object. It can be a list. And each one of these attributes has a specific type that is type checked when passed from Terraform core. Each attribute also has properties. It can have a description, use descriptions. It can be optional. It can be sensitive, so it will not show up in the Terraform output. It could be a lot of other attributes. And it can also have optional validators to check that the value passed from the user is defined correctly, according to what the provider expects the data to look like. It's all implemented in a schema. No, don't see the breakpoint. Inside the schema method. And you can see that the resource itself has a description, and each of the attributes also has a description, if it's required or not required. And validators, in this case, it expects the file name to be a simple file name, just as a demo validator. It also expects the lines array to have at least 2 elements. So list validator, size at least 2. And this is, if you pass a smaller array to that, an error will be returned back to the user specifying you need to have at least 2 elements in the array. Just again, example of validators. And I said use the descriptions because when you use the descriptions, Terraform, the framework, will generate documentation from that. The documentation will read the descriptions and render correctly. No, not render correctly. But it will read the documentation, create an empty file, and then this empty file will have the descriptions inside that it's copied from the descriptions in the schema. So use that. It will be easy for users. Later on, this is published into Terraform registry. The plugin framework are not native Golang types. It's important to understand because you need to translate them. They have additional methods that handle null values, that handle unknown values. Like, for example, an int64 has an is-null method that will return true or false if it's null. Golang by itself doesn't have a null concept on its primitive types. So there needs to be a bit of adaptation on that. You can access the primitive values with the value primitive name, like value for an int64. You can also cast collections into Golang type with as methods. For example, a list has an element as that will cast the list into a Golang slice. And you can use that to access the data inside that. So if you look at that again, you can see, where is that? The create operation accesses the file name with data, which is the struct that's returned from Terraform core, dot file name, which is the name of the attribute in the schema, dot value string to cast it into a string type, a native Go lang string type, and then you can use it to pass it on to different attributes. Created a provider, written provider, it looks good. You want to start running it. At first, you will run it locally on your machine. We won't publish it to Terraform registry till it's at least good enough to run. To allow an override, you use a tfcli config file. You define it as an envar. You define a file. And this file makes Terraform core read a local path instead of reading from the registry. So you can see there's a mapping between registry.terraform.io/h-safra/file to the path that on my local Mac, that is where the compiled executable goes, and it reads the file from there. You can use log-based debugging, prints system output to see for simple use cases or for tracing. For more complex cases, use debugger-based debugging. Obviously, debuggers are nice. We love them. You do that by running the plugin with -debug with a parameter -debug equals true. It will output an environment variable. You set that as an environment variable in the terminal window that you want to run, and then you do the action that you want to run. It looks like this. So I have the provider here. So this is the provider directory. Can I zoom in? Yes, I can. Great. I'll be able to read. So this is the provider directory. It has the executable, the compiled execute, Terraform provider file data. It's always Terraform-provider- the name of the provider. And I have a sample directory here that has a few different configuration options. So there's a resource file that defines a resource, two resources, actually two files. And you can see that it maps into a file. Nothing too fancy here. And if I run plan, it will tell me there's no errors. And if I delete file 1 and run the plan again, it will tell me that it wants to create a file. And I can also do it obviously with apply and create a file. Nothing too fancy here. And first of all, if you want to, and you can see the output of the plan looks like this. Now let me just export. And thank you, Warp. I really love Warp for the history. When you define the Terraform CLI config file, which looks like this, as you see in earlier in presentation, and you run Terraform plan again, it will give you a warning saying, please note, this is development by overrides are in effect, and I'm going to read the provider from the local executable and not from registry. Now that it can cause you errors if you don't see that. Let's unset that. And if you run, say we want to debug the read operation, for example. Obviously, we start with a breakpoint inside the read operation. Oh, I have a breakpoint. You define a configuration, a run configuration, each with your own favorite ID, but you pass -debug equals true. When you do that and you run when you debug, it will compile the code and run it and I had to reboot the Mac, and will output this line. This line is and the ID and of the socket in the line is what attaches the Terraform core run executable to this debugging session. And if I go ahead and export that, and I do a run a Terraform plan, you'll see that the debugger will pop up and allow me to debug operations and see that I want to read the path from file 2. For example, obviously the run, it's still hanging here because it's waiting on the debugger. And when I reset the run again, it will read the second file. And then it will return with no changes. Never mind. Created the code, debug the code, create acceptance tests to allow automatic testing. It will help you run when you run locally. It will also help down the line when you need to bump versions, when the dependabot says you have to, there's a new version of the plugin framework or one of the other million things that it depends on. Acceptances run automatically inside the GitHub action pipeline that's provided with the repos. Use them. It will save you time down the line. It's It's automatic testing, obviously, for resources or data sources. The state is check implicitly by the testing framework. And you can also run it manually with the make test ack. You create the acceptance test by adding a file called the resource name _test. And this file has a few things. It has a test suite that you define. Oh, sorry about that. It has a test suite you define. This test has 2 tests. This test suite has 2 tests that's running. That's about file 1, and then an update to the values. And there's a function down at the bottom that defines and actually returns a Terraform configuration file. You see a provider file data with a path and a resource with templates that you can template in. The template's over here. Ooh, I have the template's over here. And they get passed from the test ack. And this will create dynamic create a configuration file for each of the steps. Don't have a lot of time now. After you created that, this obviously is publishing into the Terraform registry. So you start by creating a GPG key because it's needed by Terraform registry. You said that if you want to use automatic provisioning to the registry, not manual, and use that, it's easy. You need to set the GPG private key and passphrase inside the GitHub secret and create a tag. If you don't create a tag, nothing will work. So create a tag, VN semantic version. Everything is based off of that. And then you log into the Terraform registry and add your repo. When you add your repo, it will do an initial copy into the registry. It will also set up webhooks inside your repo that will cause the registry to get notified about new versions or new tags that you push into your repo and get automatically applied into Terraform registry. So it all gets bundled up, and then when you push a new tag into your repo, it will automatically go ahead and build the executables, and then Terraform registry will go ahead and grab them. To wrap it all up, we started from manual create users or scripting. In our case, it was Ruby. I had to learn Go a bit, and then create a provider, debug it more, add features. And now we're using this provider to manage users. It's been like a year now. It's all been very good. Thank you for your time. This is my contact details if you want to contact me, any questions later on. And we have 5 minutes or 50 minutes if anyone has any questions. There's a mic going on, sorry.
Yeah, my first question is, how do you manage the provider publishing for any private usage Terraform provider? Yeah, that's the question.
I don't understand.
Like the usage for example, if you use Terraform to manage any internal resources, like enterprise internal, how do you manage the provider? Because based on my understanding, the registry is for public use.
Yes, the registry is for public consumption. Everyone can grab the provider from the registry and use them. But you have to remember the provider doesn't have any business-specific knowledge about your infrastructure. It defines how to create a server or how to create a user. And creating a Postgres user, for example, is pretty generic. It has a create user with login, blah, blah, blah. If you're fine with your generic code that is not business specific to be open and for others to benefit it, you can publish into the registry. If you don't, then you need to run it like the debug side when you use local overrides that I've shown earlier.
So what we end up doing is just to build a container image that has the plugin.
Yeah.
We don't have any aspiration of signing up for the Terraform enterprise contract to
you do not have to sign for Terraform provider for Terraform enterprise contract to publish.
No, I'm talking about to use the private registry. They only provide private registry for
okay. That's something that you can decide. I was fine, and my company is fine with contributing it back to open source, and for everyone can use that and clone it and use it again as they wish. But obviously, if you have something proprietary in that, and that's not possible. It's a public registry.
Yeah. My second question is, how do you do acceptance tests in terms of, do you do mock-based tests, or you just targeting your provider against the real thing with the real?
No, the acceptance test has a Docker image with an Aerospike server. This provider provisions Aerospike users and roles. So it spins up a Docker image with Aerospike version 6 and 7, and then it will run the test on that inside a GitHub Action runtime. So it's not the real provision. It's not the real infrastructure. It's a mock system.
Okay, makes sense.
This gentleman over here.
What is the contract with the Terraform registry? If you publish a tag with a faulty code on your side, Is there you get some notification or?
No. I don't believe Terraform Registry does any kind of code scanning or anything to that. They have an assumption that your code works. What you contribute to Terraform Registry is an executable. You build it yourself. You build a release on your own repo, and Terraform Registry will get the executables and copy them into the registry. You don't contribute actual source code, but executables, and these executables can do whatever you wish to do.
Okay, gotcha.
If you want to spread viruses around the world, it's possible. Way back over there. Throw the mic.
Okay. Do you know that the process is the same for OpenTofu as open source deliverable from Terraform?
I don't know for myself because I haven't tried that. When I created the provider, it's just after HashiCorp is changed from GPL to BSL, and OpenTofu was a bit of a voodoo. It was called OpenTF when it first started. So I went with the beaten path of creating a Terraform provider and didn't test it. I can only assume that it's roughly the same because Tofu started from a fork of everything that HashiCorp had around Terraform, including a provider framework, including the Terraform core itself. So I can assume it's basically the same, but I haven't tried it for myself now.
Okay, thanks.
Thank you all. I will be very happy to discuss anything else with you.